pause for a moment and ask yourself, could we be living in the rarest solar system in the entire universe? One so unique that billions of stars cannot replicate it. If that is true, then the arrival of Earth, of life, and of us may be the most delicate story the cosmos has ever written. A system where small inner worlds dance close to the light, while giant guardians keep watch in the dark outer reaches. Like a cosmic symphony arranged with impossible precision. In this video, we dive straight into that mystery, tracing every clue Gaia and Kepler have left scattered across decades of observation. And you, the one watching, share your first thought. Is our solar system rare, or have we simply not looked far enough yet? Now follow me forward, because the next question unlocks the entire journey. Why might our solar system be the rarest in the universe? Imagine the Milky Way breathing in its ancient silence. A vast ocean of starlight stretching across a darkness so deep that even memory seems to dissolve into it. And inside that ocean floats our fragile little system. 8 planets encircling a yellow star like seeds drifting around a warm ember. For decades we believed this pattern was ordinary, that the universe surely repeated its designs like a craftsman with infinite time. But the more we looked, the more we listened to the radio whispers of distant suns, the more we realized something unsettling and strangely beautiful. Among thousands of stellar families we have discovered, none look like ours. Not even close. It is a thought that moves through the mind like a soft wind across open water, gentle at first, then impossible to ignore. Are we rare? Or are we simply blind? Number is less than 1 hash is greater than. The astronomer Geoffrey Marcy once said, every new discovery reminds us that nature's imagination is vastly greater than our own. And perhaps that is where our story begins. Not in certainty, but in humility. Because every time we lift our telescopes toward the stars, we are not only searching for worlds, we are searching for context, for the cosmic backdrop that tells us who we are and how improbable our existence may be. The puzzle unfolds slowly, like an ancient tapestry being unrolled under candlelight. We have identified more than 5,000 exoplanets, and tens of thousands more are waiting quietly in the data. But in this immense archive of alien systems, there is no pattern resembling the one that raised Earth. Instead of small rocky planets in the inner zone and great wandering giants outside, we see systems of peas in a pod, worlds nearly identical in size and mass, following each other like siblings walking a narrow path. We see chains of super-Earths hugging their stars, and hot Jupiters swirling in impossible proximity. What we do not see is a twin of our own delicate arrangement. The astrophysicist Sean Raymond once murmured, if the solar system is normal, then most of the galaxy is very strange. And if the galaxy is normal, then we are the strange ones. His words linger like smoke in the air, shaping themselves into a question that feels older than the planets themselves. Why did our system grow the way it did, with small worlds near the warmth and giant guardians casting long shadows at the edge? One answer rests in the grand tack hypothesis, a narrative as dramatic as mythology and as intricate as clockwork. In this scenario, Jupiter was not always a distant shepherd. It once plunged inward toward the infant sun, carving through the disk like a wandering titan, disturbing everything forming in its path. Had it continued its migration, Earth may never have coalesced. But something changed. Perhaps Saturn. Perhaps an invisible dance of resonances. And Jupiter reversed course, sailing outward again, leaving behind a quieter region where smaller worlds could gather themselves into being. Carl Sagan once whispered a truth that feels especially sharp here. We are rare and precious because we are a chance occurrence in a vast and indifferent cosmos. If Jupiter's journey was truly a cosmic accident, then our existence rests on a moment of celestial hesitation, a pause in the drift of giants. But perhaps the true reason we find no systems like ours is simpler. Perhaps we cannot yet see them. The astronomer Sara Seager reminds us, the universe is not obligated to make itself easy to observe. Our current tools favor worlds that scream their presence. Hot, close, large. Meanwhile, planets like Jupiter at 5 astronomical units whisper, completing lazy orbits that take more than a decade. And Earth-like planets tucked into temperate zones hide even more carefully. But Gaia changes everything. Quietly, patiently, like a scribe charting the heartbeat of the galaxy. As it measures the wobble of 8 billion stars, it reveals the gravitational shadows of giant planets we never had the eyes to see. Soon, the data will show us whether systems like ours are common, uncommon, or nearly impossible. And that question carries a weight that touches both science and the soul. If we are rare, then life itself may be a delicate flame, flickering in only a few corners of the universe. If we are common, then the universe may be rich with histories, civilizations, and minds staring back at the stars with the same longing we feel tonight. As I reflect on this vast riddle, I find myself returning to a simple thought, a gentle lesson shaped by decades of looking upward. The universe does not owe us clarity, but it rewards curiosity. We learn not because the answers are easy, but because the questions awaken something ancient in us, something that remembers what it means to wonder. And perhaps that is why our solar system feels so precious. Not because it is guaranteed to be unique, but because it reminds us that existence itself can be fragile, improbable, miraculous. When I imagine those other worlds, some scorched, some frozen, some locked forever in twilight, I feel a quiet gratitude for the narrow window of conditions that allow oceans, forests, and human breath to exist at all. My personal view drifts between hope and humility. I suspect the universe is far more creative than we imagine, that systems like ours may hide in the data, awaiting the moment we finally learn how to see them. But I also believe rarity does not diminish our meaning. It amplifies it. We are the consciousness of a small system that dared to ask the cosmos about itself. If you have ever looked at the night sky and felt the strange mixture of insignificance and wonder pressing gently against your heart, then you already understand why this question matters. Because to ask whether our solar system is rare is to ask whether life is common, whether intelligence is inevitable, whether we are part of a grand choir or singing alone in the dark. As this thought settles, like stardust drifting through a quiet room, I invite you to breathe with the universe for a moment. Let the question echo inside you, soft and luminous. And if this journey moved you, if it stirred your curiosity or deepened your sense of wonder, gently tap the like button. Subscribe to stay with us on the long drift through the cosmos, and share your thoughts in the comments. Do you feel our solar system is truly rare? Or do you believe countless unseen twins are waiting in the dark between the stars? Number is less than. 1 hash is greater than. As we drift toward the next chapter, let the question guide us like a lantern held up in the void. For the path ahead unfolds into a deeper mystery. One that begins with a whisper and widens into a revelation. Why might our solar system be the rarest in the universe? Imagine drifting through the quiet fabric of space, where every thought becomes a ripple, and every question a soft echo in the dark. In that drifting state, one question rises again and again like a luminous tide. Number, what are the true conditions that allow life to bloom in the universe? We look at Earth, our only example, a fragile blue sphere wrapped in clouds and memory. And we wonder why life chose this world and not the countless others scattered like sparks across the void. Carl Sagan once whispered that life is the universe knowing itself, and in those words lies a reminder that our existence is not inevitable. It is conditional, dependent on cosmic balances so delicate that even a minor shift might have erased us before we began. Perhaps it starts with Earth's mass, just heavy enough to hold an atmosphere, just gentle enough to avoid crushing its own possibilities. A planet too light would bleed out its breath into space. A planet too massive would smother its chemistry under unbearable pressure. Earth stands between those extremes like a tightrope walker suspended over eternity, kept steady by gravity's soft but firm hand. And yet mass alone could not have sung the first notes of life. So we drift onward, following the trail of conditions like constellations leading toward a hidden truth. The next answer glows in the idea of the habitable zone, that fragile band where starlight is neither too fierce nor too faint. Here, water can remain liquid, the universal solvent, the quiet architect of cells and oceans and storms. Astronomer Stephen Kane once said, "Water is the handwriting of habitability, a signature we search for across the galaxy as though following the traces of a cosmic author." But the habitable zone is not a guarantee, only an invitation, a doorway rather than a destination. Even planets inside this golden band may be barren deserts or frozen vaults, untouched by biology. Earth, somehow, managed to turn this opportunity into a thriving tapestry of complexity, a rare feat that deepens our wonder about what other conditions may have nudged it along the path to life. We drift further back in cosmic memory, to the star that warms us, an unassuming yellow dwarf whose stability has been our silent companion for nearly 5 billion years. Stars are not equal in their generosity. Some flare with deadly ultraviolet bursts, some dim too quickly. Some swell into giants long before life can take its first breath. But the sun, steady and composed, has burned with just the right calmness, the right rhythm, the right lifespan. Astrophysicist Natalie Batalha reflected that habitability is not about a moment. It is about stability across eons. And in those words, one feels how deeply our existence leans on the quiet patience of our star. If the sun were more violent, more chaotic, more brief, perhaps nothing more than simple molecules would ever have formed here. Yet there is another presence in the story, a guardian often overlooked but essential, the giant that circles in the outer dark with storms older than civilization. Jupiter, the colossus whose gravity has shaped our history in ways subtle and profound. Alan Stern once remarked, "Without Jupiter, Earth's biography might have been much shorter." For this giant, swirling with lightning, guarded the inner worlds from the worst of the cometary storms, sweeping away threats, absorbing wanderers, shaping the architecture of our system with a strength Earth could never possess. Jupiter is like an elder sibling standing watch at the edge of the family, powerful enough to shield, distant enough to let the smaller worlds dream in peace. But even as we name these conditions, another thought rises like mist from deep time. Are these truly rules, or merely the peculiar blessings that shaped our own story? Life elsewhere may obey laws we do not yet understand, may emerge in worlds we would dismiss as impossible. Some scientists whisper that methane seas, ammonia oceans, or even exotic chemical substrates could serve as the canvas for alien biology. In that sense, perhaps we are not describing the requirements for life, but the requirements for our kind of life. A subtle but profound difference. Still, there is something poetic in the way Earth fits into its cosmic cradle, as though nature stitched every detail with deliberate care, even if randomness was the true author. A planet of just the right weight, circling a star of just the right calmness, resting in a temperate zone of just the right light, guarded by a giant of just the right size. The philosopher in us sees symmetry, the scientist sees coincidence, and the dreamer sees meaning. Perhaps all three perspectives are needed to fully appreciate how precarious and precious our existence is. As we drift further through this cosmic meditation, one truth glows softly beneath every idea. Life is not simple, not inevitable, not easily repeated. It requires a harmony of forces, a balance of light and shadow, a choreography of matter and energy that spans eons. And yet, the very fact that it happened once, here, on a lonely blue world in a vast spiral galaxy, gives us permission to search for it elsewhere. For if nature wrote this delicate song once, perhaps it may choose to hum it again across another distant shore. In these reflections, we return to the central question that drifts like a lantern across our thoughts. What truly mattered for life to rise here? And would those same ingredients be required everywhere? The answer is uncertain, like a dim star seen at the corner of your vision, clearer when you do not look at it directly. But the search continues, and with every new telescope, every world discovered, every spectrum analyzed, we come closer to understanding our place in the silent architecture of the universe. So let your thoughts drift with the current of this vast inquiry. Breathe slowly, and allow the cosmos to cradle your imagination. For the next question on our journey waits just ahead, gently glowing like a star rising over the horizon. Why might our solar system itself be one of the rarest designs in the universe? Imagine drifting through the quiet dark of the Milky Way, where hundreds of billions of suns burn in silence, each one wrapped in its own mysterious family of worlds. And among all those stars, we ask a question that feels both scientific and deeply personal. How many sun-like stars are known to host both an Earth-like planet and a Jupiter-like guardian? The answer, whispered almost apologetically by our best data, is still zero. Not a single confirmed system matches the elegant architecture of our home. A small rocky world bathed in warmth on the inside, and a giant protector circling farther out like a cosmic sentinel. Astronomer Sarah Seeger once said, "The universe is under no obligation to make sense to us," and her words linger as softly as starlight here, because this mystery cuts deeper than statistics. It touches the foundations of how life begins and survives. Some researchers argue that Jupiter was not merely an ornament in our planetary family, but a guardian whose gravity swept aside comets that could have sterilized Earth before life ever took hold. While others suspect Jupiter also delivered the very water and organics that seeded the early oceans. So if no other star has yet shown this pairing, if no other system has revealed both a warm Earth and a distant giant, are we witnessing cosmic rarity, or only the boundaries of our current eyesight? The truth is both humbling and hopeful, because our tools have grown powerful. Yet they still struggle to see the long, wide orbits where a Jupiter would glide, taking 12 Earth years to complete a single celestial step. Michio Kaku once reflected, "To understand the universe is to understand ourselves." And it is in this spirit that astronomers continue to expand their technologies. The Doppler method tells us when a star wobbles, but it favors worlds hugging their suns closely. The transit method watches for shadows, but a Jupiter-like orbit transits far too rarely for the short lifetimes of our missions. And so the data returns with a bias. A portrait of exotic systems filled with super-Earths and mini-Neptunes, but hardly any analogues of our own orderly sweep of rocky worlds inside and giants outside. Yet the story does not end there, because the universe rarely surrenders its secrets all at once. The Gaia spacecraft, moving with the slow duty of a cosmic cartographer, measures the tiniest motions of stars with a precision once thought impossible, detecting shifts so small they resemble the width of a quarter seen from the moon. If a distant sun-like star is being tugged gently by a world the size of Jupiter, Gaia may see it before we ever witness a transit or a Doppler signal. Avi Loeb once remarked, "Extraordinary claims require extraordinary evidence, and Gaia's mission is to gather exactly that, not in bursts or guesses, but in a steady, patient accumulation of truth." Its next data releases may reveal thousands of long, period giants scattered around distant suns, perhaps even the first true sister system to our own. Still, the silence is meaningful, and the absence of confirmed matches invites reflection. What if our world, balanced delicately between warmth and protection, is not a statistical inevitability but a cosmic rarity, a gentle anomaly carved out by chance interactions in the early days of our sun's birth? Some models suggest Jupiter migrated inward long ago, disrupting larger worlds that were forming near the sun, before drifting outward to settle where it is now, leaving behind a smaller, stable zone for Mercury, Venus, Earth, and Mars to emerge from the cosmic rubble. If that migration was triggered by a fleeting encounter with a passing star, as some theories quietly propose, then our system may be the result of a 1 in a billion choreography, a dance so uncommon that the galaxy scarcely repeats it. And if so, the existence of life here, thinking, questioning, dreaming, may hold an even deeper significance. Yet humility is essential, for we have explored only a tiny fraction of the stars around us, and each year brings new surprises that challenge our assumptions, reminding us that ignorance is often larger than knowledge. The possibility remains that Gaia, TESS, and the next generation of space telescopes may reveal what has been hiding in plain sight. That the universe may hold not one but many families shaped like ours, waiting for the right instruments to be heard. Astronomer Carl Sagan once whispered into the collective memory of humanity, "Somewhere, something incredible is waiting to be known, And this question feels like one of those thresholds where the incredible may be only a single detection away. So we drift here, in the soft light of speculation, suspended between awe and curiosity, wondering whether our solar system is a rare jewel or simply the first of many we have yet to see. And as we wait for the data to deepen, we allow ourselves a quiet moment of wonder, imagining what it would mean to find another Earth with its own Jupiter, orbiting a distant sun across the vast, breathing dark. Perhaps rarity is not the point. Perhaps the universe is not asking us to judge, but to listen, to look, to learn. And, until the next discovery arrives, we travel gently through this uncertainty, held by the same delicate physics that shaped our home. In the end, the question lingers with a quiet echo. Are we rare, or simply early in our search? And as the stars glide silently through the night, the universe invites us to keep looking, for the answer is drifting somewhere out there. Imagine drifting through the quiet corridors of the galaxy, where starlight falls in slow silver waves and the ancient breath of the cosmos still echoes from the dawn of time. In that gentle darkness, one question rises like a lantern, floating upward into the void. Why is it so difficult for us to find another planetary system that truly resembles our own? For decades, astronomers have swept their instruments across the sky, listening for the faint gravitational footprints of distant worlds, hoping to find a family of planets arranged with the same delicate balance that shapes the architecture of our solar home. Yet the more we search, the more we discover how unusual our cosmic neighborhood may be, how finely tuned its harmony appears when compared to the worlds beyond. The first challenge rises from the nature of motion itself, from the fact that planets do not shout their existence. They whisper it through the subtle wobble of their stars. Astronomers call this the Doppler method, a way of sensing the tiny sway of a star as unseen planets tug it one way and then the other, painting their presence in shifts of starlight too small for ordinary eyes to perceive. This method has revealed worlds burning close to their suns, hot giants whipping around their stars in a matter of days, worlds so different from ours that the comparison feels almost dreamlike. But Jupiter, the great guardian of our solar system, moves on a much slower path, one that takes more than 12 years to complete. Its immense orbit means the wobble it produces is broad and lazy, a long, deep breath that unfolds over decades. Detecting such motion requires patience on a scale that human research rarely enjoys, and thus Jupiter twins in distant systems remain hidden behind the veil of time. As Dr. Jeff Marcy once remarked, the planets we are best equipped to find are usually the planets least like our own. His words linger like stardust, reminding us that our tools shape our discoveries, and that our blindness is often technological rather than cosmic. The Doppler technique favors the bolder worlds, the ones that move quickly and leave sharp signatures. But the quiet giants, the keepers of long orbits like Jupiter, require a deeper stillness to be seen. The second challenge lies in shadow rather than motion, in the rare alignment that allows a planet to drift directly across the face of its star, dimming the starlight for a moment as though writing its name across the glowing surface. This is the transit method, the technique that turned the Kepler mission into a treasure chest of thousands of worlds, each discovered because their geometry happened to align with our fragile line of sight. Yet even this brilliant strategy carries its own limitations. For to confirm a world, astronomers must witness its transit at least 3 times. And that is where the vastness of nature stretches far beyond the patience of our instruments. because a planet like Jupiter would require more than 30 years of continuous observation to reveal its rhythm. Kepler watched the heavens for only 4, a blink in cosmic time. So the great outer planets remain elusive, drifting like silent titans far from their suns, too slow to mark themselves in the brief stories our telescopes have written so far. As Dr. Natalie Batalha often says, the universe is generous, but it reveals itself only to those willing to stay long enough to listen. Her sentiment echoes the truth that the architecture of our solar system unfolds across decades and centuries, and that we cannot expect the secrets of Jupiter worlds elsewhere to unveil themselves quickly. Beyond these obstacles lies an even deeper matter, the question of formation, of why our planets orbit as they do, and whether that arrangement is typical or incredibly rare. Many discovered systems appear compact, with worlds of similar size clustered close to their stars like beads on a string, a configuration astronomers call peas in a pod. Our solar system, however, breathes in a wider rhythm. Small rocky worlds inside, giants ruling the outer reaches, and a vast gulf between them. That gulf is the kingdom of Jupiter, whose presence may have sculpted the early solar disk, sweeping away material that once might have formed super-Earths near our Sun. Without Jupiter, the Earth we know might never have existed, or might have been lost in the shadow of a larger rival world. Dr. Alessandro Morbidelli once reflected on this mystery, saying, "Jupiter may be the reason Earth is Earth." His words hold an almost mythic weight, hinting that the fortunes of habitability may depend less on the presence of a single planet than on the choreography of an entire system. To find a solar system like ours, we must find not just an Earth twin, but a guardian giant in a slow, wide orbit, a star of the right type, and a harmony of distances that allows both stability and wonder. With such delicate requirements, it becomes clear why the search is so challenging, and why every new method feels like a small lantern pushed deeper into cosmic night. This is where astrometry steps in, the art of measuring a star's precise position against the backdrop of infinity, looking for the gentle loops it draws as unseen planets pull it through space. Gaia, with its twin telescopes and exquisite timing, has begun to detect these celestial dances, revealing worlds whose long orbits were invisible to previous generations of instruments. The promise of Gaia is immense, for it allows us to sense distant Jupiters without waiting decades for a full orbit, and it widens our window into the architecture of planetary families across the galaxy. Yet, even with Gaia's brilliance, the search remains an act of patience, a slow unfolding of cosmic truth, a reminder that the universe does not bend to our schedules. We are learning to see planets the way time sees them, in cycles deeper than our own lifetimes, each world drawing a curve of motion so large that it feels almost like a lullaby written in gravitational notes. And through all this, a quiet emotion rises, the sense that perhaps our solar system truly is rare, not by miracle, but by the improbable intersections of physics and chance. As Carl Sagan once mused, we are the custodians of a legacy given shape by cosmic coincidence. Our home may be a statistical outlier, a beautiful arrangement nature seldom repeats, or perhaps we have simply not yet watched long enough to witness the slow worlds reveal themselves. Drifting through these ideas, we are invited to consider our place anew, to imagine that the rarity of our system is not something that should isolate us, but something that should fill us with gratitude, with humility, with awe. We are children of a planetary family whose harmony is ancient and fragile, and the difficulty of finding its likeness among the stars only adds to its quiet majesty. As we continue to observe, to listen, to let decades pass in the slow gathering of data, we edge closer to the truth of whether our home is a cosmic rarity or merely one verse in a larger galactic poem. Until then, we drift forward, suspended between curiosity and wonder, held gently within the silence of the universe. In the quiet dawn of modern astronomy, before we learned to read the faint tremors of distant suns, no one imagined that the first confirmed worlds beyond our own would be found in a place where life could never bloom. A pulsar, a dead star spinning with the cold precision of a cosmic metronome. Yet in 1992, we heard a whisper in its pulse, a rhythmic delay so delicate it bordered on the unbelievable, the gravitational tug of planets orbiting a stellar corpse. The discovery felt less like astronomy and more like a revelation, a reminder that the universe rarely follows the stories we expect. As the astrophysicist Alexander Wolszczan mused, if planets can exist around a pulsar, they can exist almost anywhere. From that unlikely beginning, the search expanded outward, guided by the subtle language of starlight. Ripples of motion measured through the Doppler method, where a star's breath, drawn toward us or away, paints its story in stretched and compressed wavelengths. But this approach was biased by its own limitations, revealing only the heaviest worlds, boiling giants clinging close to their suns, monstrous planets whose gravity stitched tight orbits in mere days. These early detections led some to wonder whether our solar system, with its small inner worlds and calm giant neighbors, was an oddity rather than a rule. As Sarah Seeger once reflected, the universe was showing us planets we never dreamed of, and withholding the ones we expected. But astronomy has always been a discipline shaped by patience and persistence. And in 2009, a new pair of eyes opened in orbit, unblinking and devoted to one purpose: to watch, for years, as 150,000 stars flickered imperceptibly in the darkness. Kepler did not search for planets directly. It listened for the soft dimming of a star as a world crossed its face. A cosmic shadowplay repeated over and over across the sky. And with that quiet method, the night blossomed with planets. Thousands of them. Small, rocky, tightly packed, circling their stars in intimate configurations we had never seen in our own backyard. The discovery of these compact systems left astronomers humbled, reminding us that nature favors diversity far more than familiarity. As Kepler's principal investigator William Borucki remarked, every time a new planet appeared in the data, it felt like the universe turning a page. Through these decades, the narrative of exoplanets has flowed like a slow river, carving new channels through our understanding, moving from the improbable worlds around pulsars to the hot Jupiters pressed against their suns, then to the forests of super-Earths and mini-Neptunes orbiting in tight formation. This shifting picture forced us to ask hard questions about our own existence. Was our solar system ordinary, or an outlier sculpted by rare cosmic accidents? The contrast grew sharper with every new catalogue, every new system that looked nothing like our own. And yet science rarely settles into certainty, for each answer reveals a deeper mystery, and every dataset becomes a doorway to the next question. When we look back now, the timeline of discovery feels almost meditative, like a slow unfolding, a flower opening one petal at a time across the vastness of decades. The pulsar planets whispered that worlds could survive catastrophe. Doppler giants taught us that our expectations were too narrow. And Kepler showed us that the galaxy is overflowing with worlds beyond imagination. In this gentle drift through cosmic history, it becomes clear that our first discoveries were not the answers but the overture, a prologue to a far grander symphony of planets waiting in the dark. And as we float on this current of knowledge, the universe continues to murmur its secrets, reminding us that every world, even the strangest, has something to teach us about our own. Imagine drifting through a silent ocean of starlight, where each point of fire hides a family of worlds circling in the dark. If you could glide close enough to listen, to feel their rhythms, you would discover something quietly astonishing. Most planetary systems in our galaxy are not arranged the way ours is, not even close. Their worlds tend to resemble one another, aligned like pearls on a cosmic string, similar in size, similar in mass, similar in story. Astronomers call this the peas in a pod pattern, a gentle phrase that hides a profound truth about how nature usually builds systems. As the Kepler mission revealed its thousands of distant silhouettes, a kind of quiet consensus emerged. Many stars carry chains of super-Earths and mini-Neptunes that hug tightly to their parent suns. They move in close orbits, often near resonant rhythms, like dancers repeating steps learned from the same ancient teacher. In these systems, the planets are siblings in the clearest sense, sharing the same proportions, the same materials, the same gravitational upbringing. Their harmony is predictable, elegant, almost serene. But when we turn back to our own solar system, the music changes. The inner worlds are small, rocky, fragile. Mercury, Venus, Earth, Mars move like delicate seeds scattered near the warm breath of the sun. Then, suddenly, far beyond the frost line, the score expands. Jupiter rises like a colossal guardian. Saturn follows with its cathedral of rings. Uranus and Neptune drift in a slow blue dusk. This architecture is not normal, not ordinary, not something nature seems inclined to repeat often. The astrophysicist Sarah Milholland once reflected, "If you look at the planets of a single system, you can almost guess the rest. But when you look at ours, it defies prediction entirely." Her words hang in the mind like cold starlight, because they point to a possibility many scientists hesitate to say aloud. Perhaps our solar system is not just unusual, but profoundly rare. When researchers examined hundreds of multi-planet systems, they found a repetition that bordered on poetic. Worlds shaped by similar pressures, formed from similar reservoirs of dust and gas. Yet something disturbed that same rhythm here, in the very place we call home. Some astronomers point to the Grand Tack model, a story in which Jupiter migrated inward like a wandering giant before retreating outward again, carving away larger worlds that might have formed closer to the Sun. The planetary scientist Alessandro Morbidelli described this event with a kind of cosmic awe, saying, "Jupiter may have rewritten the entire blueprint of our system, leaving behind a smaller inner world and a safer cradle for life." If this migration truly occurred, then the solar system becomes less a typical family and more a survivor of celestial upheaval. A place sculpted not by calm, steady growth, but by a near-catastrophic reshuffling. a drama we may never fully reconstruct. It paints our world not as an ordinary outcome, but as something closer to an intricate accident. And yet, even accidents can produce beauty. Earth's existence may owe itself to those early disruptions, to the fragile conditions that allowed oceans to gather, continents to rise, and consciousness to bloom like a spark in the cosmic night. The physicist Michio Kaku once remarked, "If you want to understand why we are here, you must understand the rare choreography of our solar system." His voice carries a weight that seems to echo across time, inviting the listener to consider that we are not only observers, but participants in a story billions of years in the making. The contrast between typical planetary systems and ours grows starker each year as new data flows from telescopes scattered across Earth and space. Researchers now find super-Earths so regularly that their absence here feels like a deliberate omission in some cosmic pattern, as though our system were painted in a style the universe rarely chooses. Many scientists admit quietly that if aliens examined thousands of planetary systems, they might treat ours as an oddity, a misfit, a curiosity tucked in the outskirts of the Milky Way. But perhaps that strangeness is meaningful. Perhaps it is a reminder that complexity often grows in the margins. When the astronomer Eric Ford studied the peas in a pod trend, he observed, "Nature prefers symmetry, but breakthroughs often come from broken symmetry." Those words unfold gently into the heart of our solar system's mystery. Its broken pattern, its imbalance, its contrasts between tiny and titanic, warm and frozen, ordered and chaotic, may have been exactly what allowed life to slip quietly into existence. As we drift further through this idea, the universe begins to feel less like a vast emptiness and more like an ancient library. Each system a different page. Each orbit a different sentence. Most pages repeat a familiar verse, but ours reads like a rare poem tucked between the lines. A poem shaped by collisions, migrations, and long-forgotten storms. If you close your eyes for a moment, you can almost feel the early solar system swirling around you, dust dancing in the newborn light, Jupiter's gravity tearing paths through the haze, Saturn singing its cold, ringed harmonies. There is a strange serenity in imagining how improbable this place truly is. And so we continue to search, to count, to compare, hoping to find another system that mirrors ours, or to accept that we may be wandering through one of the galaxy's rarest arrangements. With each discovery, each new data release from Gaia and Tess, the question grows sharper, more luminous. Why does the universe prefer harmony? And why did our home emerge from discord? In this slow drift of thought, in this meditative current of starlight, one truth glimmers softly. To understand who we are, we must understand the improbable beauty of the system that holds us. To understand the rarity of our worlds, we must listen to the quiet music of those that are not like us. And as we float deeper into the cosmos, the question lingers like a final note suspended in space. Is our solar system a common chapter in the universe? Or is it a solitary verse written only once? In the quiet drift of cosmic time, when we look back toward our own solar system with the same tenderness one might reserve for an old photograph, a simple truth begins to shimmer beneath the surface. Our home is strange, beautifully, profoundly strange. The arrangement of small, rocky worlds huddled near the sun, guarded by a procession of giants in the outer dark, is not the rule of the galaxy, but the exception. And the deeper we search through the exoplanetary sensors of Kepler, TESS, and Gaia, the clearer this truth becomes. We live inside a system shaped by an ancient act of celestial violence and improbable grace. Astronomers call the explanation for this rare choreography the Grand Tack hypothesis, a name borrowed from the maneuver of a sailing ship changing direction on open water. It suggests that in its youth, our solar system was not a peaceful nursery, but a stormy sea through which Jupiter itself carved a path of upheaval. According to this picture, the young Jupiter began its life not as a distant guardian, but as a wanderer drifting inward toward the infant sun, its gravity stirring the primordial disk like a giant hand sweeping through mist. This inward motion was no gentle approach. It was a migration powerful enough to distort the destinies of worlds not yet born. As Jupiter pushed inwards, it passed through the region where super-Earths and mini-Neptunes commonly form in other systems. Worlds that in countless exoplanetary families become the dominant members of the inner realm. But in ours, they never had the chance. Jupiter's gravity scattered this early generation of large planets, flinging them into the sun or ejecting them into the dark spaces between stars. The region that should have belonged to them was left scraped clean, reduced to a thin, wounded ring of debris. From this impoverished material, the small rocky planets we know today began to rebuild themselves. Their existence is a quiet testimony to survival, to rebuilding after catastrophe. Earth, Venus, Mercury, Mars are not the planets our system first attempted to create. They are the second attempt. And then, just as dramatically as it had advanced, Jupiter reversed course. Something in the disk, perhaps the pull of Saturn forming behind it, caused the giant to halt its charge and sail outward again. Planetary scientist Alessandro Morbidelli once described this moment with a calm wonder that has stayed with many researchers. The solar system, he said, remembered the shape it wanted to be. Jupiter's retreat allowed the young inner planets a moment of peace, a chance to stabilize, to cool, to become worlds capable of oceans and atmospheres and futures. The rarity of this migration has led astrophysicist Sean Raymond to remark, if the Grand Tack really happened, then we are living in the planetary equivalent of a survivor's tale. It is a sobering idea, one that makes the familiar arrangement of our system suddenly fragile, like pottery that only exists because the kiln flared at just the right moment. But even as this hypothesis explains the small inner worlds, it also sheds light on the giants themselves. Jupiter, Saturn, Uranus, Neptune. Each occupies an orbit that seems almost mathematically arranged, balanced, like notes in a chord that has been tuned and retuned over billions of years. Their spacing, their masses, their quiet gravitational grip on comets and asteroids all whisper the same thing. Our system has been sculpted, not simply accumulated. And the evidence extends far beyond our own skies. When we look at other planetary systems, we find worlds packed close together, worlds of nearly identical size, worlds orbiting so tightly that years pass in days. Peas in a pod, as astronomer Lauren Weiss famously described them. Yet ours is not a pod, it is a mosaic, a collection of contrasts so sharp they seem almost artistic. Why, then, did Jupiter move the way it did? Why did the disk respond the way it did? And why did all of it resolve into the architecture we see now? The universe does not often give reasons, but it gives patterns. The grand tack suggests that planetary systems are not formed. They are sculpted by conflict, by migration, by the invisible tension between gravity and memory. When I imagine the early solar system, I see Jupiter as a restless ancestor, pacing in the fog, searching for a home it had not yet found. The smaller worlds are like children who survived the temper of a giant. Their lives defined not by what they were given, but by what they endured. And Earth, delicate yet resolute, is the quiet beneficiary of a history that could have erased it before it ever began. Astrophysicist David Stevenson once said, "To understand why we are here, we must understand why Jupiter is where it is." It is a sentence that grows heavier the longer you hold it, because it reminds us that habitability is not only about the right temperature or the right atmosphere, but about a choreography of giants. And still, the story deepens. Missions like Gaia and Tess reveal more exoplanetary families each year, yet none with the same mixture of austerity and asymmetry that marks our own. Perhaps somewhere in the galaxy another Jupiter once plunged inward and then retreated, rewriting its system in the same rare script. Or perhaps our solar system is one of only a few, or one of one. As we drift through this thought, it becomes almost meditative. We exist because of a gravitational accident, or a cosmic intention, or a balance that emerged after eons of trial and collapse. The universe does not say. It merely offers the silence in which we may wonder. And in that silence, the grand tack becomes more than a theory. It becomes a reminder that creation is rarely gentle, that beauty often follows upheaval, and that the serenity of our nights is built upon ancient storms we will never see. So when we ask why the solar system looks the way it does, we are also asking why Earth survived, why oceans formed, why consciousness had a place to bloom. The answer may lie in Jupiter's long arc through the dust, a cosmic wanderer whose journey carved the stage upon which every human moment now rests. And as we continue our search among the stars, one question lingers with a soft, steady pull. If the grand tack is truly a rare celestial dance, then what does that make us? The quiet species born in its wake. Imagine drifting through a quiet corridor of starlight, where every system you pass hums with its own hidden rhythm. Somewhere out there, beyond the faint glow of our familiar sun, lie thousands of planetary families that look nothing like our own. And within that vast cosmic mosaic, one question returns again and again like a tide that refuses to rest. Why is it so difficult to find the Jupiter of another star? Astronomers often say that nature hides its largest secrets behind the slowest motions, and Jupiter is the embodiment of that rule. It takes 12 long Earth years to complete a single orbit, a gentle giant drifting in a wide circle that unfolds at a pace almost meditative. Kepler, the great watcher of the sky, stared at its patch of stars for barely 4 years. A blink for us, and even less than a heartbeat for a world like Jupiter. And because the transit method requires 3 passes across a star to even whisper the existence of a planet, Kepler simply never had the time to catch the long journey of these distant giants. Their shadows never repeated often enough to rise above the noise. The Doppler method, so elegant in its sensitivity to stellar wobble, is like listening for a soft breath in a raging storm. It can measure the pull of a giant planet. Yes, but only if we focus on one star at a time. And the universe offers too many stars and too few lifetimes to listen deeply to each one. As the astrophysicist Jeff Marcy once said, "The galaxy is whispering its planets to us, but we can only lean in so close at a time." His words echo a bittersweet truth, that our tools can hear the wobble of Jupiter-like worlds, yet cannot sweep across hundreds of thousands of stars in a single breath. Even so, scientists keep searching, because planets like Jupiter may hold the quiet keys to life itself. Many researchers have suggested that Jupiter acted as Earth's shield, catching comets, deflecting asteroids, and calming the violent storms of the early solar system so that life could grow. As the planetary scientist Alessandro Morbidelli once remarked, "Without Jupiter, Earth might have been nothing more than a scarred rock spinning alone in the dark." If such guardian giants are crucial, then finding them around other stars becomes more than an astronomical curiosity. It becomes a search for the possible homes of life. And yet, the very things that make Jupiter gentle and stable also make it nearly invisible to our current surveys. It orbits too slowly, too far out. Its gravitational signature spread thin over the decades. The universe hides its guardians behind patience, and we humans are rarely patient enough to see their full motion unfold. Still, change is coming. New missions like Gaia track the positions of stars with a precision once thought impossible, watching for the slow, graceful curves that reveal a massive planet tugging gently at its parent star. These tiny celestial arcs, almost imperceptible, may soon unveil a population of Jupiters we never knew existed. As astrophysicist Amina Helmi said about Gaia, "For the first time, we are seeing the galaxy breathe. And in those faint breaths, Jupiter-like worlds may finally reveal themselves." Yet even with Gaia's growing treasure trove of starlight, one truth remains as soft and persistent as interstellar dust. The planets most like our own giant guardian are simply the hardest to catch. Their long orbits stretch beyond our patience. Their transits slip through the cracks of our brief surveys. Their gravitational wobbles whisper softly from systems too numerous to study one by one. The cosmos hides its masterpieces behind time, and time is the one resource astronomers cannot accelerate. But perhaps this difficulty is not a barrier, but a kind of invitation. A reminder that some discoveries require us to slow down, to breathe with the rhythm of the orbit, to listen for the faintest tremors of motion across decades. In the quiet spaces between measurements, between hopes and confirmations, science becomes something more poetic, a practice of patience that mirrors the timeless movements of the stars themselves. When we contemplate the challenge of finding another Jupiter, we are really contemplating the scale of our ambition against the scale of the universe. We are reminded that life on Earth may owe its existence to a planet we almost never see, a guardian whose story unfolds too slowly for the hurried pace of human observation. If other Jupiters exist, they too may be cradling the possibilities of life, shaping the fates of worlds we have yet to imagine. So the challenge is profound, but it is also beautiful. We stand at the edge of a cosmic ocean, waiting for its slowest waves to reach us. Not with impatience, but with a kind of reverence, knowing that each new detection carries the potential to reshape our understanding of life's rarity and Earth's place in the great symphony of creation. And as you drift with me through this quiet reflection, Consider one gentle question that lingers like stardust in the air. If Jupiter was essential for us to exist, then what does it mean that its twins are so difficult to find? Perhaps the universe is asking us to look deeper, to listen longer, to move at the pace of planets rather than the pace of people. And in that slow cosmic rhythm, we may finally discover whether our Jupiter is a rare guardian or just one voice in a vast chorus of giants waiting patiently to be seen. In the quiet drift of the cosmos, where light takes its time and silence becomes a kind of ancient language, a new storyteller has appeared at the edge of our understanding. Its name is Gaia, a satellite that does not look outward into the infinite so much as it measures the subtle trembling of stars, the way a musician might sense the vibration of a distant string. And in that trembling, Gaia may be rewriting everything we thought we knew about planetary systems, perhaps even about how rare or common our own celestial home truly is. Astronomers have long suspected that the great secrets of distant worlds were hidden not in the planets themselves but in the faint sway of the stars they orbit. That sway is microscopic, the width of a quarter as seen from the surface of the moon. Yet Gaia reads it as easily as one reads a pulse beneath the skin. This is astrometry, the science of measuring position with such precision that even a wandering giant a billion kilometers away leaves a signature impossible to deny. A large planet pulls at its star, tugging it gently in a cosmic dance, and the star responds with a motion, small but graceful, like a candle flame bending toward a passing breeze. Gaia captures that bend, that tiny deviation, and from it reveals worlds no telescope has ever witnessed directly. As Dr. Scott Gowdy once remarked, "A star cannot hide its planets forever. It always betrays them in its movement." What makes Gaia extraordinary is not just its sensitivity but its patience. For more than a decade, it has swept the sky again and again, marking the positions of over 1 billion stars, each observation becoming a whisper of a larger story unfolding. Planet hunters have used Doppler shifts and transits for years, but these methods favor the dramatic, the close, the hot, the fast. They reveal planets that kiss their stars with impossible proximity, worlds that scorch and shimmer with each orbit. But Gaia listens to a different kind of planet, the slow ones, the cold ones, the giants that wander the outskirts of their star systems like ancient guardians. As Dr. Sarah Seeger beautifully stated, "If transits let us see planets when they shout, astrometry lets us hear them when they merely breathe." And it is these breaths that matter, for the great question haunting astronomy is whether other stars host their own versions of our Jupiter, a world whose gravity may have shaped the delicate clockwork of the early solar system. Without Jupiter, Earth's story might not have unfolded. The bombardments might have been too violent, the orbits too unstable. Many astrobiologists quietly suspect that a Jupiter-like planet might be a prerequisite for long-term habitability, a cosmic shield in the darkness. And yet, after more than 30 years of exoplanet searches, we have found almost no systems that resemble ours. Maybe we are rare, or maybe our tools have simply been blind to the giants lurking far from their stars. Gaia is the first mission capable of lifting that veil. Already, it has uncovered super-Jupiters around small, faint stars, systems once thought nearly impossible. The discovery of Gaia 4b and Gaia 5b was a reminder that the universe still enjoys surprise, that the catalogue we believed complete was only an opening chapter. And according to the astrophysicists modeling Gaia's future releases, we may soon be awash in revelations. Thousands of massive, distant planets, worlds that eluded every prior method, may reveal themselves as the next datasets arrive. Dr. Joshua Wynne described the moment well when he said, "Gaia is about to show us the architecture of planetary systems we didn't even know we were missing. And when we possess that architecture, we may finally confront the question that has lingered for decades. Are planetary systems like ours rare? Or are they simply subtle? To know this is to know something of the likelihood of life, of worlds where oceans breathe and atmospheres dream. The thought drifts like a tide through the mind, quiet yet profound. There is a kind of meditative beauty in imagining Gaia mapping the heavens, drifting through its orbit in silence, watching the stars quiver against the black fabric of space. Each tiny wobble it records is a message, a signature, a promise that another world is out there. Some of those worlds might be gas giants wrapped in storms bigger than our planet. Others might be icy wanderers, moonlit and silent. And somewhere hidden in the statistics, there may be a system very much like our own. If Gaia finds many Jupiters, our solar system might not be the rare jewel we once imagined, and the universe could be brimming with stable, Earth-friendly environments. If it finds almost none, then the fragility of our existence becomes even more astonishing. As Dr. Michel Mayor, co-discoverer of the first sun-like exoplanet, once reflected, to know how common worlds like ours are is to know our place in the universe. So we wait, not with impatience, but with the calm curiosity that astronomy teaches. The stars move slowly, and Gaia listens slowly, and in that slowness there is wisdom. The answers will come with the rhythm of orbits, with the breathing of galaxies, with the mathematical poetry of motion inscribed on the sky. Perhaps in the end, Gaia will not merely catalogue planets. It will remind us that every star has a story, every wobble has meaning, and every world, no matter how distant, leaves a trace in the universe that speaks of its existence. And maybe, just maybe, one of those stories will mirror our own, a distant cousin of the solar system, a place where another blue planet circles a warm star under the protection of a silent giant beyond. Until then, we drift with Gaia, through the meditative vastness of space, waiting for the moment when the faint trembling of a star quietly rewrites everything we thought we knew. The silence between the stars is never truly empty, and Gaia has been listening to that silence with a patience only a machine in the deep can possess. For years it drifted through the darkness, tracing the faint trembling of starlight, measuring the smallest motions of suns many light years away. And then, almost quietly, it revealed something that astronomers once thought was nearly impossible. Two immense worlds, Gaia 4b and Gaia 5b, giant planets far heavier than Jupiter itself, yet circling stars far smaller and gentler than our Sun. Their presence is a soft disturbance in the cosmic fabric, a wobble so delicate that only Gaia's unblinking vision could notice it. Some called such systems too rare to exist at all. Others said their orbits were improbable, unstable, unlikely to last. But Gaia watched, and Gaia waited, and Gaia found them. And in that discovery lies a deeper whisper from the universe, a promise that these giants are not alone. As Dr. Joshua Wynne once said, Every time we find a planet that should not exist, we learn that our imaginations have been too small. His words drift gently across the evidence, reminding us that reality always outpaces prediction, always surprises the tools built to measure it. Gaia 4b and Gaia 5b are heavy worlds wrapped in shadows, circling small, cool stars like ancient guardians of forgotten realms. Their orbits stretch wide, far from the warmth of their suns, creating stellar wobbles that unfold over years rather than days. Graceful arcs detectable only through the finest astrometric vision humanity has ever crafted. These worlds are unexpected, not because giant planets are rare, but because giant planets paired with such tiny stars seemed almost contradictory to the standard rules of formation. Yet here they are, evidence that the cosmos does not always follow the scripts we write for it. Their existence forces us to question our old certainty that small stars cannot cradle massive companions, that certain combinations of mass and orbit belong only in theory textbooks. Gaia's discovery is like finding a whale circling a lantern instead of the vast ocean. Improbable at first glance, and yet profoundly revealing once understood. As the astrophysicist Didier Queloz once reflected, the universe is under no obligation to make sense to us, and yet it speaks in signals we are finally learning to hear. And Gaia hears much more than two lonely giants, because where there are a few detectable worlds, there are usually many hidden, waiting, quiet. The data suggest a vast population of distant gas giants may be veiled within Gaia's measurements, each one leaving behind a faint stellar sway, so subtle that only long spans of observation can bring them into view. Imagine thousands of stars moving in tiny ellipses, each curve a secret signature of an unseen planet. They are like fireflies behind thick fog, invisible to the eye, but undeniable once the pattern becomes clear. The truth arrives slowly in astronomy, carried not in bursts but in rhythms, in the patient accumulation of data, in the gentle refinement of uncertainty. Gaia shows us that the universe is far more crowded with giants than all previous missions suggested, that the architecture of solar systems is stranger, broader, more diverse than the early catalogues ever hinted. No longer can we imagine planetary systems as tidy rows of mini-worlds aligning neatly around their suns, because Gaia has illuminated a truth both wilder and more beautiful. And yet, there is a softness to this revelation, a reminder that even monumental scientific progress can feel like meditation when viewed from afar. The slow unfolding of stellar wobbles, the gentle arc of a star across Gaia's sensors, the quiet certainty that something massive is tugging from the dark. All of it creates a kind of cosmic breath, an inhale and exhale measured across light years. As Dr. Natalie Batala once reflected, every world we discover reshapes our understanding of who we are and where we belong. Gaia's discoveries do exactly that, shifting our sense of rarity, of normalcy, of the fragile balance that gave rise to Earth. If massive planets can exist around stars once thought too small to host them, then how many other rules of creation are waiting to be rewritten? And so we drift with Gaia through its ocean of measurements, letting the data settle like dust in gentle gravity, understanding slowly that these first super Jupiters are only the beginning. In the years to come, Gaia's full archive may reveal not dozens, but tens of thousands of such hidden giants, planets that reshape the map of our galaxy and redraw the boundaries of possibility. In this unfolding story, Gaia has become less a satellite and more a lantern, shining softly through the cosmic haze, illuminating the silhouettes of worlds we once believed too rare to exist. And as we listen to these faint stellar tremors, we are reminded of Carl Sagan's quiet truth. Somewhere, something incredible is waiting to be known. Gaia has shown us the first shadows of that incredible something, inviting us to keep drifting forward, to keep watching, to keep wondering what other giants are breathing softly in the dark. In the soft darkness between the stars, where silence gathers like ancient dust, the promise of Gaia DR4 and DR5 drifts toward us like a slow-turning lantern. For decades we searched for worlds beyond our own, listening for faint dips in starlight, measuring tiny shivers in stellar spectra, hoping that somewhere out there a pattern would emerge that resembles home. Yet what we found was a universe far stranger, richer, more unpredictable than any dream our telescopes first dared to imagine. And now, as we wait for Gaia to open its next 2 chapters, we find ourselves standing on the threshold of a transformation so vast that even seasoned astronomers pause to breathe slowly before speaking of it. When Gaia DR4 arrives in 2026, it will bring with it at least 7,500 new exoplanets, each one a tiny gravitational whisper recorded across years of patient watching. The satellite has traced the delicate wobble of stars with a precision that astrophysicist Jos de Bruyne once described as equivalent to measuring the width of a human hair from 1,000 kilometers away, a feat so improbable it borders on poetry. And hidden in those wobbles are worlds we have never been able to see before, giants wandering far from their stars, cold and steady, in regions where our older surveys were blind. There is a quiet reverence in the scientific community when speaking of what Gaia is about to reveal, because DR4 is not merely a list of planets. It is the first true map of the architecture of distant solar systems. We will see where the giants live, how far they roam, and how often they settle into orbits that resemble our own Jupiter. If Jupiter really is the silent guardian that shielded Earth during its infancy, then knowing how common such giants are becomes the first serious step toward answering whether life arises easily or only under rare celestial choreography. As the astronomer Sarah Seeger once said, "Every new exoplanet is a new piece of the cosmic puzzle that shows us who we are and who we might be." But DR4 is only the inhale, a gentle preparation for what follows. When Gaia DR5 arrives in the early 2032s, the sky will open fully. More than 120,000 exoplanets are expected to emerge from its decade of data, a 20-fold expansion of everything humanity has found so far. This is not evolution. It is revolution. A shift so enormous that our understanding of planetary systems may fracture and reform entirely, the way a continent breaks and drifts to form new worlds. Imagine hundreds of stellar neighborhoods unfolding before us in exquisite detail, each wobble on the sky painting the silhouette of an unseen giant, each curve of motion revealing old gravitational stories that were written long before Earth existed. Imagine opening a catalogue of systems not by tens, but by tens of thousands, until patterns that were once invisible suddenly bloom like constellations. Will we discover that planets form in families of similar size, as the peas in a pod pattern suggests? Or will Gaia unveil entire categories of systems we never knew to expect? Will we see Jupiter analogues in abundance? Or will their scarcity confirm that our own planetary configuration is deeply uncommon? As astronomer Didier Queloz once reflected, every time we think we know how planets form, the universe gently corrects us. And Gaia's corrections may be profound. For the more distant giants it uncovers, the more complete our picture becomes. Through the combination of Gaia's astrometric ballet and Tess's careful search for inner worlds, we will finally begin to see entire systems from the inside out. A Jupiter found by Gaia, an Earth found by Tess, both circling the same star, the first true analogue of our home. If such a system appears even once, it will be a quiet earthquake in astronomy, a confirmation that Earth-like worlds with protective giants are not myths whispered in the dark. But if it does not, if Gaia and Tess together search thousands of stars and find almost none with both an Earth and a Jupiter, then we may have to face a more unsettling truth. As physicist Freeman Dyson once mused, the universe may be stranger than we imagine, but it may also be stranger than we can imagine. There is something meditative in the way Gaia's future hangs before us, a slow unfolding like the petals of a cosmic flower opening under starlight. The satellite does not shout its discoveries. It accumulates them through patience, through repetition, through the simple act of watching a star shift its position by the width of a breath. In a universe measured in billions of years, Gaia practices the oldest discipline of cosmic understanding, waiting. And as we wait with it, we feel something stir within us, a mixture of humility and anticipation. Because DR5 will not simply expand our catalogue, it will redraw the boundaries of what we think a solar system can be. It may reveal that our own system is an oddity, a cosmic outlier born from a rare chain of gravitational accidents. Or it may reveal that we are one melody in a vast symphony of worlds, each system echoing the same quiet logic that shaped our sun and its companions. As the stars drift and Gaia continues its silent survey, we are reminded of a simple truth whispered by Carl Sagan. Somewhere, something incredible is waiting to be known. And Gaia, with its patient clocks and twin telescopes, is reaching for that something even now. So let us breathe with the rhythm of the cosmos, slow and steady, as the data gathers and the future approaches. Gaia DR4 will open the door, and Gaia DR5 will carry us through. By the time its revelations settle, we may know at last whether our solar system is rare, remarkable, or simply one thread woven among countless others in the great tapestry of the galaxy. Until then, we drift in wonder, suspended between what we know and what we are about to learn, listening to the quiet promise of a spacecraft that is teaching us to see the universe with new eyes. In the quiet drift of the cosmos, there is a question shimmering just beneath the surface of our curiosity. If Gaia can trace the faint trembling of a distant star, and if Tess can feel the soft shadow of a small rocky world passing in front of its sun, then perhaps, for the first time in human history, we stand on the threshold of seeing another version of home reflected somewhere in the dark. Astronomers have long whispered about this possibility, about finding a system where an exo-Jupiter breathes slowly in the cold outer regions between 1 and 5 astronomical units, while a small Earth-like world circles closer in, warmed just enough for seas to exist and chemistry to awaken. The vision feels almost mythical, because for decades our instruments were blind to such harmonious architectures, unable to sense both giants and terrestrials together, like listening to an orchestra yet only hearing either the deepest drums or the highest flutes. But Gaia, with its impossible precision, measures the sky the way a monk might listen to the heartbeat of a mountain, each stellar wobble recorded with reverence, each deviation becoming a clue to hidden worlds. Meanwhile, Tess sweeps the heavens with patient eyes, catching the gentle dimming of starlight as planets transit through their cosmic routines. Astrophysicist Sarah Seeger once said, "Every star could be a sun, and every sun could cradle a world like ours." Her words linger softly as Gaia and Tess begin their shared search. Two instruments, separated by design, yet united by purpose. From Gaia we receive the whisper of large, distant wanderers. From Tess, the signatures of worlds small and warm. And when these two sets of data finally overlap, something extraordinary may emerge. Michio Kaku once remarked that finding a true solar system analog would be like discovering a cosmic twin that answers the oldest questions we have about ourselves. The idea is seductive, not because it flatters our sense of significance, but because it gently humbles us, reminding us that life as we know it might not be a cosmic accident. Yet the opposite possibility holds equal weight. Avi Loeb has often warned that absence of evidence is not evidence of absence, but sometimes it tells a story. And if Gaia finishes its grand survey and finds that exo-Jupiter worlds are abundant yet almost never paired with Earth-like planets, then the story may reveal something deeply sobering about our own origins. In the slow rhythm of deep time, the rarity of such a configuration could whisper that our solar system is a fragile choreography, a coincidence of gravitational balances, migrations, and ancient disruptions that allowed Earth to remain serene while Jupiter stood guard at the frontier. Carl Sagan once mused that we are rare and precious because the universe needed time to make us. And perhaps the architecture of our system is part of that long crafting. It is a poetic thought, but also a scientific one, because no theory of planet formation today can easily recreate both an inner chain of small terrestrials and an outer kingdom of giants without improbable conditions. Gaia and Tess offer the first empirical path to resolve this tension. And so we drift deeper into this unfolding mystery, carried by starlight and the tireless patience of instruments orbiting far above us. Imagining a moment when the data aligns, when an exo-Jupiter is mapped in the cold, and a small Earth-like world is seen crossing the warm face of the same star. If that day comes, the universe will feel suddenly less lonely, the silence less vast. But if the catalogues remain empty of solar system analogues, if the great maps fail to show our pattern mirrored anywhere, then perhaps our home is not simply rare, but singular. The thought does not frighten, it invites awe. For to live in a unique cosmic structure is to live inside a miracle of physics and chance. As the stars continue their eternal drifting, Gaia's final measurements and Tess's continuing watch will bring us closer to truth. A truth about whether the universe easily makes worlds like ours, or whether Earth is a quiet exception in an ocean of possibilities. And as we breathe with the rhythm of this slow cosmic meditation, we wait, gently suspended between hope and humility. Imagine drifting through the quiet corridors of the galaxy, letting the mind float between starlight and shadow. In that vast silence, a single question begins to echo with the weight of eternity. Are systems like ours rare, or are they scattered everywhere like hidden lanterns in the dark? The answer is not a small curiosity. It is a compass for understanding life itself, for knowing whether Earth is a cosmic accident or part of a grand pattern woven through the Milky Way. Carl Sagan once whispered that the universe is not required to be in perfect harmony with human ambition. Yet the very existence of our gentle blue world makes us wonder if that harmony was written into the void long before we appeared. If planetary systems like ours are rare, then Earth becomes a fragile exception. A single note trembling in a vast expanse of silence. A world whose oceans, continents, and delicate climate may be the improbable result of an exquisite cosmic alignment. Astronomer John Gribbin once mused that we are alone because we are unique. And that idea carries both awe and ache. A reminder that consciousness may have blossomed only once in a universe filled with cold stars and indifferent dust. If this is true, then humanity is a kind of miracle, a flame no other corner of the galaxy knows. It would mean that systems with small rocky worlds inside and protective giants outside are not merely uncommon. They may be cosmological rarities. But if systems like ours are common, if the architecture of Earth and Jupiter repeats itself across spiral arms and star nurseries, then the story changes completely. It means the cosmos is generous, fertile, abundant with opportunities for life to spark and grow in countless hidden valleys of light. Harvard astrophysicist Avi Loeb once suggested that life might be the norm under the right cosmic conditions. And if that is true, then Earth is not a lone lantern, but one of many glowing worlds. Perhaps somewhere on a distant planet, oceans breathe beneath unfamiliar skies, creatures dream with minds unlike ours, and civilizations raise their eyes toward their own constellations, wondering the same thing we do now. As we glide deeper into the question, the uncertainty itself becomes a quiet beauty. Astronomy often moves slowly, like sediment drifting in a still lake, and the answer to whether we are rare or common unfolds the same way. For decades, our telescopes found mostly hot giants lurking close to their stars, hinting that perhaps systems like ours are scarce. But Gaia whispers a different possibility, one revealed through the faint wobble of stars pulled gently by distant giant companions. Each wobble is a syllable, each shift a clue, and together they may form a message that our solar architecture is not a cosmic fluke, but part of a quiet, repeating design. If that turns out to be true, the implications are profound. Life would not be a solitary flame, but a constellation of fires, scattered across the Milky Way. Perhaps evolution is not a rare choreography, but a cosmic rhythm, one that worlds fall into when the conditions are kind. And even if intelligent life is rare, microbial life could be widespread, filling hidden oceans, cloud layers, and ancient craters with patient, silent chemistry. Yet there is an equal poetry in the opposite conclusion, that we are the rare embodiment of the universe trying to understand itself. Physicist Brian Cox once reflected that the cosmos could be empty, and that makes us immensely valuable. That thought settles over the mind like dust made of ancient stars, soft, infinite, humbling. If Earth is a singular oasis, then every dream, every story, every fragile moment of consciousness becomes a treasure the universe may never produce again. It turns human existence into a responsibility, a duty to preserve this improbable branch of cosmic memory. The truth is that both possibilities are equally wondrous. If we are rare, we are precious. If we are common, we are connected. And in either case, the universe becomes not a cold, empty abyss, but a place filled with meaning, waiting for us to discover it slowly, thoughtfully, like travelers following lanterns through fog. We may float here on this small blue cradle, staring outward with instruments of glass and metal. But the question we ask is ancient, whispered by generations who looked up before us. And as telescopes sharpen, as Gaia and Tess continue their quiet vigil across the sky, we draw ever closer to an answer that will reshape our place in the cosmos. Perhaps we will discover twins of our solar system, scattered like seeds through the spiral arms. Or perhaps we will find only silence, and realize that we are the single improbable bloom in a dark cosmic forest. Either way, the universe invites us to wonder, to listen, to drift in its vastness with humble curiosity. And as we continue this journey, the question remains suspended before us like a soft glowing star. What does the rarity or abundance of systems like ours truly say about life itself?